In this video, we are going to see how to calculate the percent yield and theoretical yield of the reaction of acetanilide with potassium chlorate giving parachloroacetanilide. Acetanilide is a benzene ring with an amino group, and one of the hydrogens is replaced by an acetyl group, which is COCH3. So this is a benzene ring, and if I replace one of the hydrogens with an amino group, it becomes aniline. And if I replace one hydrogen of the amino group with an acetyl group, which is COCH3, then I get acetanilide. Potassium chlorate is KClO3. So in this reaction, we have acetanilide reacting with KClO3 to give us parachloroacetanilide. And we are doing this in the medium of glacial acetic acid using concentrated HCl as a catalyst. Now to calculate the theoretical yield, let's find out the number of moles of acetanilide used. Molecular weight of acetanilide is 135 grams per mole. Mass of acetanilide used in the experiment is 0.4 grams. I'm going to say 0.4 XX, and you can write down the 3 decimal places as per the mass that you weighed from the analytical balance. So number of moles is 0.4 XX over 135 grams per mole, and you should get, if we use 3 significant figures, it will be 0.00296 moles because we have 0.4 XX which has 3 significant figures. On the side, just to clarify how we got the molecular weight of acetanilide, we have 8 carbon atoms. If you look at the structure, 1, 2, 3, 4, 5, 6, 7, 8. And so 8 times 12, which is the molar mass of carbon, is 96. We have nine hydrogen atoms, 5 on the ring, and then we have a methyl group and a carbonyl group. So 9 times 1 is 9. 1 oxygen atom, 1 times 16, and we have 1 nitrogen atom, so that would be 14 times 1, and if you add everything up, we get the molecular weight of acetanilide, which is about 135. Now coming to potassium chlorate, molecular weight of potassium chlorate, KClO3, would be, potassium is 40, chlorine is 35.5, three oxygens with 16 grams per mole each, so 3 times 16 is 48, and you can add them up to get the molecular weight of potassium chlorate. Now mass of potassium chlorate that you used is 0.13 grams. So we can find out the number of moles of potassium chlorate used, which would be 0.13 x grams, because I'm going to use 3 significant figures, and that divided by 123.5, which is the molar mass of potassium chlorate, and that gives us 0. 0.00105 moles of potassium chlorate. So now we have to find out the stoichiometry between acetanilide and potassium chlorate. To do that, let's write down how chlorine is generated from potassium chlorate. So potassium chlorate plus HCl gives potassium chloride plus chlorine plus water. It is this chlorine Cl2 that chlorinates the acetanilide. KClO3 has 3 oxygens and water has 1 oxygen. So to balance that, let's put a 3 near water. Now there are 6 hydrogens on the right hand side because 3 times 2 is 6, and so let's put a 6 for the HCl on the left hand side. Now we see that potassium is actually balanced. There is just 1 potassium on both sides, and there are 7 chlorine on the left side and 3 chlorine on the right side. So if we put a 3 in front of the chlorine on the right side, we should have 7 chlorines on both left and right side, and that should be balanced. We see that 1 mole of potassium chlorate gives us 6 chlorine atoms, 6 moles of chlorine atoms, and 1 mole of potassium chlorate reacts with 1 mole of acetanilide. So there are 6 times chlorine atoms present, and so we have to multiply 0.00105 by 6 to get the number of moles of chlorine atoms, and that gives us 0.0063 moles of chlorine atoms. Now to find out which is limiting and which is excess, let's compare the number of moles of chlorine atoms to the number of moles of acetanilide. So clearly 0.00296 moles of acetanilide is less than 0.0063 moles of chlorine, so acetanilide is the limiting reagent and chlorine is in excess. Which means the number of moles of the parachloroacetanilide formed will be equal to the number of moles of acetanilide. So the theoretical yield will be 0.00296 moles, and the percent yield is going to be your actual yield, which you will be weighing over the theoretical yield, which is 0.00296 times 100.